Welcome to another Teacher Tobin video. We're going to be talking about the Edexcel GCSE Computer Science Topic 2, subject of adding binary numbers, which will cover this 2.1.4/5 specification within the curriculum. And we'll look at some exam questions as well. Adding binary numbers, because the last two videos we talked about what bits are, what bytes are, representing binary numbers and converting from denary and back and forth. Then we've also looked at 2's complement, representing negative numbers. Let's just deal with positive unsigned integers for now, just to start off, and then we'll look at an example that uses negative numbers as well later in this video. So I'm going to make up 2 binary numbers. Just going to make them up, and I'm just going to put the values up here, which I suggest you do to get familiar with them. The least significant bit, 2 to the power 0 is 1. Most significant bit in an 8-bit system, 1 byte. 2 to the power 7, 128. So total pattern 256. Okay, so I'm just going to make up a number. Let's have nothing there. Let's have a 64. Let's have a 0. Let's have a 1, 0, and a 1 and a 1. So what was that? 24, 88, 88, 91. Okay, so that equals 91. Count them all up. And if we want to add another number, I'm just going to, let's say 58. Okay, so 58 would have nothing here, nothing here. We would have 32 because that goes into 58. And plus 16 is our 48, so we need 10, so we need an 8 and a 2. Get rid of those. So that's our 58. And then we want to work out what the addition of those 2 numbers would be. Now, I'll show you what the books show you, and I'm going to give you a method which I think is slightly better. So the books will say, remember 0 plus 0 equals 0. They'll say 0 plus 1 equals 1, and then they'll say 1 plus 1 equals 0, carry 1. That's what the books will tell you to memorize, right? Which I don't think is always that helpful, because there are certain scenarios where you have 1 plus 1 plus 1. What do you do then? And I've seen those in exams before. So I'm going to give you a slightly better method. I think is better anyway. So let's have a look. Let's just do this one first. So I'm going to use a different color. 1 plus 0. Well, we put the 1 in there because we can follow that rule here. 0 plus 1. If we've got a 0 and a 1, we put the 1 down. Here we go. Now we've got something interesting here. We've got a 1 and a 1. And so what it says is put a 0 in there and then carry a 1. So I'm going to put the 1 up here. I'll put a little note, say carry. And then 1, 0, 0. Well, 0 is nothing. And then we just drop down that 1 into here. Okay. Then we've got this other issue here of 1, 1. Okay, so we can put 0 in here, carry the 1. But this is where your book is going to be annoying, because now we've got 3 1s to total up together. And you're thinking, well, I've done everything that the Bite Size and various Pearson books have told me to do. What do I do if there are 3 1s? Well, my method would be to look at the binary representations of those numbers. So I'm just going to make a little column here. I'm going to use 4 bits, which you should remember is called a nibble. 1 would be 0, 0, 0, 1. 2, 0, 0, 1, 0, 3, 0, 0, 2 plus 1, because that column's worth 4, that's worth 2, oh sorry, that column's worth, let me just go back, that's 8, that's 4, and that's 2 plus 1. Alright, those are the values. 4, nothing for the 8 column, got 1 for the 4 column, nothing for 2 and 1. 5, here, and what you can start to see is we can use this to add up pretty much any amount of binary numbers we want, because we can just represent them in binary. So if we've got our tricky issue of 3 ones, what do? Well, we put this in. So we can put in 1 plus 1 plus 1 is a 3, so I'm going to put a 1 in, carry the 1. And that was the one that I put in there, and this is the one I put over here as a carry. Now we've got 1 plus 1, so we're back to our bog standard notes that we put in. Oh, why did it say 1 plus 1, 0, carry the 1? It's because of this, isn't it? So 0, carry the 1, 0, carry the 1. There we go. So what we have here is done a very typical binary addition kind of question, but we've added that extra little missing link, which was where the misconception could probably come in when you're taking the exam. And but I don't like this method because it doesn't really tell me where those are coming from. It doesn't explain it that much, and it doesn't help me if I've got more than one, which is why if I'm teaching students, I show them this way, which makes more intuitive sense. And just to prove that this kind of works, I'm just going to completely make up another binary addition problem for you. So I'm just going to make them up. It's coming out of thin air, all 8-bit numbers. I haven't got any notes for these, I'm just making them up. So here we go. It's going to be a bit overkill. It's going to be pretty overkill, but why not? Why can't we add up all of those together? Why can't we do that? 1 plus 1 plus 1, well that's a 3, so I'm going to put 1 in, which is that one there, and I'm going to carry a 1. Now we've got 1 plus 1 plus 1 plus 1, well that's 4, so I'm going to put that 0 down here, that 0 in this column, and then carry that 1 over here. Sorry, I've got to be careful here because I've drawn this so close together that I'm going to get myself into a pickle. Yeah, let me just double check that this is okay. So 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 plus 1 plus 1 is 0, 0, 1. Yeah, 1, 1, 1 is 3. So that 0, I probably should have put it up there as a carry, because that's going to get replaced by a 1 now, because I've got 1 and 1. Okay, so we've got another 1 to put in here. So now we've got 1, 2, 3, 4 ones to deal with. So I'm going to put 0 in there, carry a 0, carry a 1. This is going to be a better representation of it. 0, 0, 1, 1, 1 is a 3, so I'm going to put 1 in there, carry the 1, 1, 1, 1, 1, 1, that's 5 ones. So I'm going to put 1 in there, carry a 0, carry a 1. That's what it's telling me there. Then 1, 1, 1 is a 3, so I'm going to put that in there and that in there. 1, 2, 3, 4, 5. So 5, 1, 0, and 1. Whatever that is. So that's that's 128, that's 256, that's 512. So it's 512 plus 128 plus 64 plus 32 plus 16 plus 4 plus 1. That would be the equivalent of it, which I haven't worked out. I know this number is 255 for sure. So this comes up with this gives you another interesting point. I couldn't store the value of this addition within 8 bits. It was too big, wasn't it? So I'm going to get something called, in this particular scenario, I'm going to get something called an overflow error, because I need 10 bits. I actually need 10 bits to store the result of that addition. The sum of those 4 binary numbers, the positive numbers, will not fit in 8. I get an overflow error. So if my computer was, let's say my old Nintendo Entertainment System, which was an 8-bit computer, added 2 8-bit numbers that resulted in a number that couldn't be stored in 8 bits, I would get an overflow error. And there are real world consequences to doing something like that, especially when numbers get converted from, say, 16 bits to 8 bits and things get lost. Then, that if you lose some of the information there, it could be devastating. There was a rocket launch that blew up because of something like that. As a famous example, because some people weren't keeping attention to the conversion of different numbers. Let's have some exam style questions then. Let's look at this one, which is a bit easier first. The addition of these 8-bit binary numbers is required. Okay, fine. Complete the table to show the result of the addition. It's 2 marks, so the 2 marks will be each nibble being correct. So 0 and 1 is 1. 1 and a 1 is a 2. So we put a 0 in, carry the 1. 1 0 0 is a 1. 1 0 is a 1. 1 1, okay, 0, carry the 1. And this is where those notes are going to be annoying from your textbooks, because they don't give you the scenario of 1 plus 1 plus 1 very clearly. So here, to represent 3 in binary, I have to have those 2 turned on. So I'm going to put that one in there and that one over here, and then I've got, it's as simple as this. So what would these numbers be? That's 64 plus 32, 96 plus 16 is 112, and then plus 2, 114. No, I've done that wrong, haven't I? Sorry. That's 128, there's nothing there, nothing, 64, 32, 16, so 48, 56, 57, 56, 58, that's worth 2, 58. This one's 128 plus 32, so 160, and 176, so 178, because there's, 179, because there's one there as well. So 58 plus your 179 should equal this. So let's just say, quickly check, 128 237. So that would be, 128 plus 64 plus 32 plus our 8 plus our 4 plus our 1 equals 237. So you can always total up the values of your result here, just to make sure it totals up what it is. Just work it out if you've got time in your exam. If you're worried about the 1 plus 1 and how many to carry, total up these two, total up what they are individually. You know that this is going to be 237, so you could just make that a 237 number, and it would work. It would be the same. You'd get the 2 marks. So that's a little bit of a hack for the exam. If you forgot what to do if you've got 3 1s, doesn't matter. Just add up the 2, work out what the numbers are, add them up to yourself, and then make sure that whatever you put here is equal to the sum of that. So it's a little bit of a trick. The most significant bit of the first binary number has changed. Right. Explain the effect of this change on the result of the addition. Well, what they're asking you to do here is understand that, you know, we're pretty near 255, which is the biggest number we can have in an 8-bit system. So if we had a 1 here, we've got 128 added on to our value, and it's not going to be able to be stored in an 8-bit system. So you need to use words like overflow. And when you've got 2 marks, you want to have a linked explanation. So it does say explain, and use words like because. That's your go-to linking word. Overflow error, I'm just abbreviating here, but overflow error because sum cannot be stored in 8 bits. And add a bit of extra detail if you need to. You can say 9 bits are required. Okay, don't just write one thing, because you'll only get one of the marks. You've got to have a linked explanation. It was this because of this. Because isn't the only linking word, but it's the one you'll use the most for a linked explanation. And if you're really in doubt, add more information. Like you can say 237 plus an extra 128 would be this binary value, and it can be stored. I'm pretty sure it could be stored in 9 bits. Because it would be, yeah, you'd definitely be able to store it in 9 bits. Okay, so let's have a look at a more tricky question. 8-bit 2's complement is used to represent the denary numbers -8 and -1. Great. So, explain why it is not possible to apply 2's complement. So there are 2 questions here related to 2's complement, which was the previous video that I did on negative numbers. Here's the trick here. You've got to remember that that column is worth -128. And because it's a negative number that we're dealing with, we know there's a 1 in there. It can only be a 1 because we're dealing with a negative number right now. So the way this will work then is we just build up the number again. So -8 plus 64 is -64, isn't it? -128 plus 64 is minus. So we need that. We need the positive 64 because we've got a -8 to deal with. -64, and then this column's worth 32, so we need a 32. So this would be -32, -16. We're getting closer, aren't we? And then that column's worth 8, and we get our -8. So there we go. We've got our -8 there in 2's complement. So we should be happy about that. Because we built up our number, we proved it. Right. -1. -1 is quite straightforward. You literally just add them all up together. So you minus 8, minus 4, 2, minus 2, 1, minus 1. Okay. So if you start off with minus 128 and you add up all the positive values that you've got in the 2's complement system, you're going to end up with your minus 1. And here's the thing, if you can't remember the steps for 2's complement, if you couldn't even remember the addition rules, then here's my hack, my trick. Well, what is minus 8 plus minus 1? Well, it's minus 9, isn't it? Okay, so minus 9 is all you need to be able to represent to get your correct answer. So I know for sure it's because it's a minus number, that's definitely got to be 1. And I'm also positive that I've got to pretty much have the same as minus 8, don't I? I've got to have the same, almost the same as that. So this is up to here. I've probably got one of my marks, at least. I've got to get the whole result correct though to get the other mark. So what am I up so far? Minus 16. So if I want to have minus 9, I probably just want to have that as 0, that as 1, and that as 1. Because I've got minus 16 plus 4 is 12, plus the 2 is 10, plus the 1 is 9. There you go. So I need to make sure there's 0 there, and then that gives me the minus 9. So they'll be dealing with quite a lot of different concepts there. But you've just got to make sure that if you can, you know what minus 8 plus minus 1 is. So you just make sure that whatever you stick down here equates to minus 9. Even if you can't remember rules about carrying or anything, you don't really need to know that. You just need to know what the result will be and represent it in the binary. Explain why it is not possible to apply 2's complement to the 8-bit unsigned integer. So it's positive. This is a positive number because it's unsigned. And that's, well, the main issue here is that we can only have between 128 and positive 127 as our value. That's the biggest positive value that I can have in an 8-bit 2's complement system, right? And because I have already exceeded that by adding that 1 over there, it just simply won't fit in. So you want to use as much of the specific terminology as possible. And again, because it's explain, you'll use words like because. All right, they want to assess your ability to explain and understand the limitations of the 2's complement system, and that you understand that the number that you're trying to represent, the unsigned integer, is beyond the value that is possible with an 8-bit 2's complement system. So that's a bit more of a tricky exam question, but it is 4 marks, and it will give you quite a nice boost in the real exam. Good luck. If this has been helpful to you, please add a comment. If you would like me to put more explanations in about multiple binary number additions or my method here, please let me know.